Hello, my name is Dylan, and I'm going to be teaching you guys today a little bit about the basics of GDB, which is a debugger, and how to use it. So GDB is a debugger similar to other debuggers that you may have used in like Eclipse or other programs like that. And GDB is really used mostly for C, C++, and assembly. So I created a sample program, which is right here, and what my sample program does is first it prints start of program, then it creates a string literal hello world, and then it goes through and prints every character of hello world. Then right here it tries to set the first character to a capital H, and then at the very end it prints end of program and returns. So if you know about C, C declares this as a string literal, and down here when we try to set a character inside of the string literal to a different character, this is going to throw an error because pretty much string literals are stored in read-only memory, and so you can't actually write there, so this will cause an error. So if I run this program quickly, we can see that start of program prints, and then a segmentation fault prints right after that. And if we look in our program, it's actually interesting because we see the hello world printing here, but then we expected every character to print before the H, and that actually has to do with the print buffer not actually printing everything out until it sees a new line. So this is one of the many reasons why in C it can be kind of complicated to find your error, and why tools like GDB are super useful. So let's debug this program then and see what we can find about it. So in order to run GDB, you must compile this with the -G flag, and this will create the necessary stuff for GDB to then run. Alright, and then to actually debug this then, just type GDB and then the name of your binary, which in my case is TST. So then this window pops up, and then so the first thing we want to do is we probably want to set a breakpoint. So if we look at our program here, we can set a breakpoint like right before the for loop, and if we scroll down we can see that that's actually line 9. So let's do B and then 9. You can also type break, B or break will work. And then also the other way you can set breakpoints is you can actually set them at the start of functions if you just put in the name of the function. So if I wanted to put a break at the start of main, I can just do break and then main. Alright, and then to run the program we can just do run. And then we see that it actually breaks at this line. So since printf is actually a method, we probably don't want to go into that method because that'll go into the C standard library, and we already know that printf works. So in order to skip over this function, we can use next or n, and as you can see that it'll jump over to the next instruction in the program. Now there's another way to step in programs, and that's just using the step command. So if we would have stepped, it actually would have gone into the printf function, but we didn't actually want to do that. Next can also jump over loops, but in this case, if we wanted to step into the for loop, we can just use regular step, and we can see that it goes then into the for loop. So now, let's say we are in this for loop and we're stepping. Oh, see, it's going into the printf function, and we want to get out of here. What we can do is we can do fin, and this will finish whatever function we stepped into. So as you can see here, we accidentally stepped into the printf function, and then fin finishes the printf function, and then it goes back up to the top of the loop. So now if we want to skip the entire for loop, we can do fin again. Oh, it looks like we already stepped over that, so we don't need to do that again. So then if we step, and then fin, yeah, we can go all the way through there. So another thing, if we want to see the lines around where we're where we are at in our code, we can do list or L, and that'll actually show you the current part of our code that we're actually stepping through. So that's a really useful command just to see what's going on in the code around you. Another thing that we can do is if we want to see like what variables hold what values, we can use the print command or just p and then the name of the variable. So if we do print I, that'll say that I is equal to 1, or we can do p s, and then it'll show you the s variable. Another thing that you can do is you can actually do like print star and then a variable, and then that'll say what's at the location. So if we did print star of s, this will just give us the first character, because that's the first character of the memory location. And you can also enter in offsets and stuff, which is really nice to see like all the different variables that are going on in your program. So now if we keep stepping through this program, here, let me put a breakpoint right before the line that it crashes, which is going to be line 12. And now if I do C for continue, or you can just type out continue, then we break at this point. Now we know this code actually is going to cause problems, but let's step over it anyways. And we see that we segmentation fault. And also right here, it actually will tell you where in the code the problem actually occurred. But just in case we actually miss this, we can do BT, and this will give us a backtrace of the problem, which is really nice. And you can also do info frame, which this will just give you a little bit more information about the stack and where the local variables are in case you wanted to look at them in memory and like figure out what's going on in your program. This is more used for assembly, but it can still be really nice. And that is pretty much it for all of the useful commands for GDB and C. There are many more of them and you can see them online, but these basic commands can at least get you started debugging in GDB, as there's some really nice ways to look at memory and see how your program's running and what's going on. Have a great day.